To God be the glory.
Welcome back to our study, Evidence for Christianity. In today's class, we're going to continue our discussion of the design argument. But before we dive into the new information in this class, I want us to refresh and think back to some points we made in the previous lesson. First off, thinking about the design argument, it can be practically stated that design demands a designer. When we see a painting, it demands a painter. When we see a building, it demands a builder. You see, there is function that becomes obvious. There is intention, intellect. There is an end result that has order to it, which demands an origin for that order, for the cause of that design. So design demands a designer. Very common sense, practical. Let's put it a little bit in more of a formal statement. The first point is using that practical. If design exists, it must have a designer. But we assert in point number 2, the universe exhibits design. All right, so number 1, if design exists, if we can see order and function, if we can see intent and purpose, it demands that there be a designer. When we look to the universe and all that surrounds us, we see that it exhibits design. And that's where we have the conclusion there at point number 3. Therefore, the universe must have a designer. You see, number 3 follows logically. It is demanded if those first 2 points are true. And so we're going to look at and think about, like we did last time, a little bit of the characteristics of the Creator that we can glean. We talked about how the prime mover, we see motion in our universe, and this motion had to have an origin to it. When we see planets orbiting a star, when we see stars orbiting each other, when the moon goes around the earth, we have this motion, this very specific, very controlled, purposeful motion. Where did that motion come from? From the originator of it. Couldn't be part of the system, had to be outside of it. And so a characteristic of the Creator that we see from design and the motion of the laws of physics is that that Creator had to be the originator of the motion. Number 2, we talked about the logical and rational aspects of our Creator. We have a world that flows in order, follows these laws like we talked about. We have a periodic table that is nicely ordered from one element all the way down, each one standing in its own place. When we see such logical and orderliness, what does that tell us about the origin of that design element? Well, it tells us that the Creator must be logical and rational. When we see all of the information that surrounds us, we know that all of that information had to be infused into the system, had to be part of the system, placed into its right place. What does that tell us about the Creator? Well, it tells us that the Creator had all of that knowledge, understands all of that knowledge, thought about it, put it into place, put it into its logical order, started its motion, gave it the information in order to operate. When we think about all the forces, we come to our 4th characteristic we talked about, and that is omnipotence. We think about the fact that all of the force that holds us to the earth, the forces that hold our bodies together and the atoms together and the electrons around the nucleus, and we think about all of those forces are extremely powerful. Where did all that power come from? Well, it came from a source that had to create all of that power. What is that by definition? That is all-powerful. That's omnipotent. And then we talked about 2 characteristics from design that we see, a personal creator and a concerned creator. The personal creator, we gleaned that aspect that God is not just an impersonal condition. God is not just a condition that exists in the universe. Rather, it's personal because it changed. in the eternal nature of the Creator, there was a point when time was created, when our universe was created. Our universe is not eternal, so at some point in eternity, our universe was created. It takes a person with free will, with volition, with choice to do that. But then that same personal creator shows concern. And we see that in how beautiful our universe is, how well it operates, the fact that you can always depend on the physical laws, the natural laws around us. The Creator didn't have to do that. It could have been a creator that was not concerned, that didn't care for their creation, and just left it up to chaos and randomness and chance. That's not what we see. We see order and we see design, and that tells us that our Creator is concerned. All right, that reminds us where we were in our design argument discussion. In today's class, I want to look at and kind of unpack some specific categories of design. And what this will do is it will help you in your thought processes and in your thinking. When you are engaging with others about the existence of God, when you're engaging with others on their own belief, well, having examples from a variety of areas that all dovetail in, they all combine into this design argument reasoning. If there's design, it demands a designer. When we see it in nature, it means that God is outside of nature and must exist. All right, so categories of design. We're going to look at several different categories. We're going to look at a little bit of a definition and then look at some specific examples that we see in that category. And some of these examples may overlap with each other. There may be kind of combinations between the two, but I'm trying to hone in and focus in on maybe one particular aspect. All right, so our first category is fundamental functionality. All right, fundamental functionality. This is the order and function that is fundamental to so many of other processes that we see around us. All right, so thinking about things really at the basic level, the foundation level. And some of these may include things that we've discussed, the physical laws, right? The physical laws of motion, the physical laws of gravity. But on top of that, we have laws of thermodynamics, the way that heat and energy is exchanged. We have laws that govern the conservation of energy, the fact that what goes into a system has to remain coming out of the system. You can't have more or less, and the way that that energy operates and is interacted within a system has to be conserved, but it may become less useful. It may degrade. We also have laws of electromagnetism and some amazing formulas and equations that bring together electricity, brings together magnetism, and we find in our study that those two have overlapping domains. And so James Clerk Maxwell gives to us some amazing equations to help us understand. Now, Maxwell didn't create the laws of electromagnetism. He simply recognized what was already there. Some other fundamental functionality that we'll look at, some natural cycles, thinking about water cycle, carbon cycle, things that surround us, these large-scale cycles that govern us, and then also some biological cycles, cycles of plant growth and animal growth, death and decay, and even ourselves. All right, so let's think about that first example, thinking about the functionality of the earth. All right. The earth has cycles, these large-scale cycles that are in operation, right? Man has very little to do. We don't control. We are participants within this. When we think about Earth's cycles, we can think about those cycles that are connecting to the ground we walk on, right? To that rock cycle or energy cycle. We can think about the water cycle, right? That governs the rivers and streams and lakes and oceans, the atmospheric cycles that intertwine with that water cycle, how water evaporates up, reaches the clouds, condenses, It precipitates back to the earth in the form of rain or snow or hail. And it gives to us some very life-giving processes, right? Again, we're thinking about some fundamental functionality that provides general ideas, general foundations for the existence of life, for the existence of other processes that will depend on it, right? The water cycle moving things around within the biosphere. Then we have the carbon cycle and nitrogen cycle, those cycles that are important for the consumption of nutrients by plants and plant life and into the soils and all of the things that make up the ecosystems that are within the ground that we walk on. Our Earth has all of these amazing cycles, many of them independent in their functionality. They serve a specific purpose, have a specific pathway, but yet they intertwine and integrate with the other cycles, and so they form a huge collection that is working together. This fundamental functionality for Earth's cycles. And we think about plant life. We think about some of those biological cycles that we see, and it's just absolutely amazing, even to see seeds planted in the ground. So simple, so small. They have their own boundary and embodiment, but then when they're placed in the soil, the fact that they open up, they sprout, they germinate, they grow, and that growth, like we discussed in the last class, all of the information is contained within that seed. Seeds and growth and development of life is fundamental to so much of what we see around us. We need the plants to go through their processes so that the animals, right, maybe even some of those smallest animals, the insects and the bugs and the critters, we need them to go through their processes because the larger animals, which have their own cycles, right, of birth and reproduction, of growing to adulthood, of having other animal life just like their kind, we need all of that. Each one sort of independent, but yet each one crossing over. And so just the formulation and the development of life forms this foundation for order and purpose that surrounds us. And then if we think about life and we dive into it, life, we're made up of cells. It's said that the human body has maybe 1 trillion cells that's part of our makeup. In every single cell, we have DNA. We have this piece of information, this way to hold code contained within our cells. Every living thing has DNA, has these instructions, but it's so much more than just instructions. DNA has the information of life coded within it in order so that every part of the body, whether it's in growth or whether it's in repair, when we get cuts and scratches, whether it's in healing, whether it's in the reproduction of children or life after us, this DNA contains that information, fundamental to all of life around us. And you know, it's only been a number of decades that we have really even understood it. Less than 100 years to know what DNA is, to know its structure, its helical shape, to know what it is composed of, and even how groupings, sections of the DNA carry out specific processes. It's astounding. It shows to us that there was a purpose and intent, and the fact that your DNA is different from my DNA and is different from those around us, all in minute ways, but to give us a complete change when we think about our character. Now, a second category of design that I want to think about and to talk about next is fine-tuning. All right, fine-tuning. Fine-tuning is this precise balance between contributing parts, properties, or processes suitable for life, all right? So where we talked about some functionality in fundamental aspects, here we're talking about this precision. Not just does it exist and is it there, but yet it is there so precisely as that if it were varied one way or another, it would cease to work and operate in the same way with the same function. And so some general categories we might think about are some of the constants of the equations that we have, some of these constants of forces. We'll also think about subatomic particles, electrons and protons, and how precisely their mass and their charge and the ratio between their mass and charge are so unique, so set for each one of those particles. And then just thinking about the abundances of matter and antimatter. The fact that our world, our universe, is made up almost entirely of matter. That's important. All right, when we think about fine-tuning, we think about those force constants that relate to the different forces that we have. Gravity and electromagnetism. So we have the universal gravitational constant and we have Coulomb's constant. And between these two forces, both need to operate in their means and in their way. Gravity working on mass. Electromagnetism working on charge. All right? And so the relation of these two is very important for the world that surrounds us. We need both, but we need both to be at their specific levels. And so what we have discovered in science, as we recognize this orderliness that we see, is that when we unpack it and we begin to dive into what the details are, we begin to formulate equations as a way to express it. But in these equations, many times there are constants, all right? A number that is fixed so that it is always the same. No matter what masses are involved or no matter what charges are involved, this constant is always the same. But who set the constant? Why is it that that constant is the way that it is? Why is it that that constant is tuned to just that right value? Well, we didn't do it. We didn't set it. We discovered it. It was part of the world that surrounds us. It was part of what we see. It was part of our very makeup. And so we think about those subatomic particles that are influenced by these forces, protons, neutrons, electrons, things that make up the atom. Protons and electrons have opposite charges. Very important. Why? Why do they have opposite charges? It's their characteristic. It was what was given to that particular type of matter. But they have different masses. And the ratio of their masses with their charges serves a very important purpose in maintaining the consistency of a single atom. There that single atom is with protons and neutrons in its nucleus and electrons that are orbiting, maybe not in precise orbits like we think about planets, but in kind of cloud-like orbits around that nucleus. But to be contained in those orbits at different levels even, it takes very specific charges and masses relating together. And then I mentioned the matter and antimatter. Antimatter, that sounds like a science fiction type of term, right? Well, in fact, it's not. We have material particles, say like the electron. And the electron is a negative charge and has a particular mass. But we have seen in small instances, in high energy experiments, where a positron, that's a positively charged electron, same mass as an electron, but the opposite charge, that this positron has an existence, has characteristics. It is its own entity. But the problem is that when matter and antimatter interact, it releases energy. All right? If our world was equal, right? If our world was just randomness and chance, then we would have an equal number of matter and antimatter. Well, that would be devastating. We wouldn't survive. It wouldn't be possible for us to exist because the matter and the antimatter would be continually interacting, giving off energy almost like an explosion, but not, and ceasing to exist. Is that what we see? Are we worried that we might walk into a room filled with antimatter and we would cease? No. So it's amazing that our universe, this orderliness of our universe, that it brings to us this process where we have what we need. And that brings to us our third category of design, and that's the anthropic principle. All right, the anthropic principle. We might define it this way. Conditions in the universe, and for the earth specifically, are designed to support life. All right, we just talked about matter and antimatter and the makeup of atoms, protons and electrons. When we think about just that entity, but what it means for life's existence, we see that the orderliness is not just nice and lined up and in its own little space and in its own little bucket. No, instead we see that where it is there in support of life. And so two examples that I want to think about, thinking back to the Earth and thinking about our orbit, and also thinking about what it is that surrounds Earth. So thinking about our orbit. Our orbit is sometimes called the habitable zone or the Goldilocks zone. All right? It's the Goldilocks zone, referencing back to a story where this young girl needed to, she was looking for just the right thing, and one thing was too hot, or one thing was too cold, or one thing was too hard and too soft. Okay. The habitable zone is perfect. All right? When we think about Earth and we think about our orbit around the sun, we are not too close to the sun as to receive too much radiation. At the same time, we're not too far away from the sun where there's very little radiation or less radiation. And so we sit in a place where the amount of energy that we get from the sun, the solar constant, 1,400 watts per square meter, reaches Earth in such a way that we have liquid water covering our surface, in such a way that we have an atmosphere that is sustainable. It's not being stripped away, it's not being burned away, it's not freezing. We have this amazing atmosphere. Now, the habitable zone, our nearest planet interior to us is Venus. Venus is just outside of this habitable zone. Mars is the next planet out from Earth. And while some estimates put Mars inside of the habitable zone, we know that Mars has very little atmosphere. It has no liquid water that we have ever seen or discovered on its surface anywhere, and potentially wouldn't even exist in that state. And so we have this precision, right? This principle of here we are in a place that has order and purpose for supporting life. That brings to our mind the idea of why are we here? Why is it this way? Who put it this way? What is the cause for the design? But let's think about our Earth singularly. Here this planet is, and yes, we do orbit the sun, but we have around us a cocoon of protection. A cocoon of protection that involves numerous layers. You know, space is a pretty hazardous place. There's lots of radiation and charged particles flying all over. And so here we sit on a planet and we hardly ever think about charged particles flying through space or high energy radiation. Why is that? It's because we sit within an atmosphere that has various layers, various densities to those layers, various electrical characteristics, and all of that to provide and support the existence of life on the surface. You see, on the outer portion of our atmosphere is the ozone, and you might have heard of this phrase, the ozone layer. The ozone is a layer of oxygen molecules that filters out, absorbs harmful ultraviolet radiation. All right? Ultraviolet radiation is that radiation that usually it gives us sunburns, right? If we spend too much time out in the sun, our skin can burn. ultraviolet light has a lot of different ranges, and our ozone layer filters out a majority of the harmful areas of it. But we also have a magnetic field. Our sun blows off streams of material. It sends out this wind of charged particles continuously, and then at moments has these major eruptions from its surface, sending out particles 1 to 2 million miles per hour. But yet these particles, when they reach Earth's magnetic field deflects the majority of these particles and lets the particles keep on going to the outer solar system. We have essentially a force field that surrounds us, different than Venus, different than Mars. We see that it has a very particular purpose and order to its design, and that design is to support life. All right, our next category is irreducible complexity. All right, this is kind of a larger term. Maybe sounds more complicated, but it's not all that complicated. Irreducible complexity. All right, I'll give you a definition from the man who kind of coined the term, Michael Behe. He talks about irreducible complexity, and he says, by irreducible complexity, I mean a single system which is composed of several well-matched interacting parts that contribute to the basic function, and where the removal of any one of these parts causes the system to effectively cease functioning. All right, so we're talking about objects, items, we're talking about entities that they have to exist together. All right, and so some examples that we might think about are our physical laws and matter, and then also a couple of design elements from life, bacterial flagellum, and we'll talk about that. All right, first off, physical laws and matter. All right, we talked about equations and forces and how there's specific constants within it, but then we asked the question, what came first? What came first, the physical law or the matter that interacts by that law? All right, so we have these two options for what came first, but really it's these two have to come together into unison. The law has no meaning outside of its expression in the physical world. If the law of gravity had no mass, if mass didn't exist, the law of gravity wouldn't exist. It would be meaningless. It had nothing to express itself. If you have mass, but you have no law of gravity, then the mass has no boundary, no mechanism or process that governs what's happening with it. And so law and matter have to come together. Charge and the electric force and the electric laws, all of these have to come into existence together. Otherwise, you have chaos or you have no meaning because there's no physical material to work with or to govern. All right, I mentioned bacterial flagellum. There's this idea that is sometimes proposed or discussed that within life itself we have an analogy to machinery, molecular machinery. All right, so in bacteria, some bacteria, they have sort of this tail-like appendage that sticks out from the body of the bacteria. And in this particular case, this bacteria flagellum is this protrusion that sticks out, except that what we see is for bacteria, it serves this very important purpose of locomotion or movement, the ability for a bacteria to move within its environment. Okay, well, we have seen this happen, and when researchers, molecular chemists, molecular biologists, when they looked into the details, what they found was astounding. What they found was this bacterial flagellum has all of these parts, that have to operate together, almost like an engine of a car, almost like an outboard motor on a boat. You have these mechanisms that are moving and spinning at high rates of rotation to create this whipping motion that generates the movement for the bacteria. You know, here from a quote I have from the Yale School of Medicine, they say the flagellum has three components: the motor, hook, and filament. The rotation of the filament allows bacteria to move around in their environment. The motor embedded in the bacterial cell membrane rotates just as a car motor spins beneath the hood of the vehicle to drive the movement of the filament outside. Now, would we say that the motor in a car just happened by random chance? Or would we say that it had some intelligent design? I think that we would say the latter. And so for this bacterial flagellum and its molecular machine, its ability to move, we would say it's designed as well. All right, now our fifth category of design is biomimicry. Biomimicry. A definition that we might use is it's the imitation of natural biological designs or processes in engineering or invention. All right, the imitation of natural designs is the definition. All right, and so I want to look at a couple of quotes from organizations that are currently involved in researching biomimicry and putting it to use, and then look at a couple of specific examples that we see where man has tried to imitate and draw information from nature. All right, thinking about the organizations, it's amazing that there are institutions, Harvard University and the Massachusetts Institute of Technology, MIT, both of these premier, prominent universities in the United States have divisions for researching biodesign, researching bioengineering or biomimicry. Also, we see the Arizona State University. Here is a quote from their website. Biomimetics or biomimicry is the emulation of materials, systems, or processes found in nature to help solve challenges in healthcare, national security, and energy. All right, so they give to us kind of this same definition that we talked about with biomimicry, and they have an institute researching this particular design direction. But here is another quote that I want to bring to you. George Washington University, Center for Biomimetics and Bio-Inspired Engineering. Here's what they say. Nature's solutions are smarter, more efficient, agile, adaptable, fault-tolerant, environmentally friendly, and multifunctional. Thus, there is much that we as engineers can learn from nature as we develop the next generation machines and technologies. You see, they are admitting that there is this orderliness and purpose and design, and it's so good that humans need to look to it. We need to understand what it has. So let's look at a couple of examples and think about them as we begin to end our time together. First off, let's think about flight. Flight in numerous systems, from birds to bats to bugs. Engineers have looked to nature for inspiration of flight. We think about airplanes that we have. We think about where the airplanes originally started and what we have today, and we see a very similar design to what birds have, right? Wings that have this curvature to them, that provide lift, that allow large bodies to seemingly float as they fly through air. Modern aircraft, ancient aircraft, have looked to these types of designs, and we see it in other forms of flight. But when we look at nature, the flight that they have is so much better than ours. The adaptability of wings, the fact that a bird can change its direction, can change the orientation and the shape of their wings, and the fact that the wings do so much more than just flight. They are their protection. They are their warmth. They are their protection from the environment that surrounds them. So flight is something that when we look at and we see birds that hover like the hummingbird, or we see bugs that fly backwards or upside down, those are things that we are trying to mimic and research institutes are trying to follow. Maybe one of the best examples of biomimicry is something as simple as Velcro. In the 1940s, there was a man, a Swiss electrical engineer, who, while going on trips with his hunting dog through fields, would come back from those trips and he'd have all these burrs in his pants and socks and shoes and boots, and then all the burrs in his hunting dog. And so he would spend time pulling all the burrs out, right? Those little seed pods and things that were connected to the plants. But at a closer inspection, he began to wonder, how is it that they stick to so many different types of surfaces so well? And so he began to look at the natural orientation of these burrs and seeds and realized that they had all these stems and projections with hooks. And that's where we get Velcro, this hook and loop mechanism where the two pieces go together and interlock. We should thank nature. We should thank God for His design that showed us this. And then one last example, thinking about biomimicry, bullet trains in Japan. These trains that are able to go at high speeds, almost 200 miles per hour down the track, taking passengers. Amazing marvels of engineering, right? A problem came up, though, that at these high speeds, when they were going through tunnels, that they would create these pressure waves and create these loud booms as they would exit these tunnels. And it was a disturbance for the environment around and the people who lived in the cities. And so they said, okay, what can we do to not have these loud booms? And so they looked at nature and said, what can we mimic for what we see? Well, there's a bird, the kingfisher. And this bird dives from the air, dives into the water, going after its prey. All right? It's entering from a low density into a higher density, and yet it does it with practically no splash or disturbance of the water. Well, that's what they did. They took that mechanism, they took that shape and structure for the beak of the kingfisher, applied it to this bullet train, and what they found was the sound was decreased, taken down where it wasn't a nuisance. But what they gained even more, they gained the ability to travel 10% faster and use 15% less energy. Less sound, more speed, less energy, all because they looked to the world around us. All right, so we looked at various categories of design. And now I ask you to think about your life, to think about what contexts there are around, and look for the design elements that are in your life, so that when you come across somebody who is questioning God's existence, you can say, hey, I've got some questions for you. I've got some ideas, things to present. Let's think about design demands a designer. And here's what points to our Creator, God.